All right, so now that we've looked at how we have developed the Pythagorean theorem and what it tells us, what we're going to start doing is using the Pythagorean theorem to help us find missing information in a triangle. So if we're given a right angle triangle, we know that a squared plus b squared equals c squared, and that means the area of the squares that we draw off of those side lengths, the two smaller areas add to give us the third area. And what we can do from that is if I know two of the side lengths of the triangle, that means I can find two areas of the squares, and I can use that information to find the missing area of a square. And if I have the missing area of a square, I can use that to find a missing side length. So what we're going to be looking at now is triangles where we know there's a right angle, and we also are given two of the three sides and asked to find the third side. So a question could look something like this. Find the missing length in the triangle. So if we look at this triangle, we see we've got our 90-degree angle right here. I know that one of the legs is 5, the other leg is 12, and what I'm missing is the information about the hypotenuse. That's my missing side length. So whenever I have a 90-degree triangle, I always want you to start off with your Pythagorean formula. A squared plus b squared equals c squared. Now when I've got that, I need to figure out what information I have. Well, we already said that we are missing the hypotenuse. We are missing the side that is across from that 90-degree angle. We are missing our largest side length. So I don't know what c is. I'm looking to find c. In terms of a and b, it really doesn't matter which one is which. Generally, I call A the smaller of the two side lengths, and then B is, I guess I should use a different color, and then I say that B of the two legs is the larger one. But it doesn't matter. You can switch them back and forth, and it would not make a difference. So I know that A, in this case, is 5 meters, and B is 12 meters. Now I want to kind of write down those units because when I look at that, I see that I have just meters. I don't have meters squared, I just have meters. So I know this is a side length. And I know that B here is a side length. I'm not given A squared, and I'm not given B squared. I'm now going to substitute the information that I have back into my formula. So instead of writing A, I'm going to write 5. And this now becomes 5 squared. And then after I have 5 squared, I'm going to change B, and B is going to become 12. And this is now 12 squared. And then C, I still don't know what it is, and I'm going to find C squared. Now, looking at this, 5 squared and 12 squared. Remember, we had to find the area of the two squares, and I have to find each area separately before I can add them together. And this is where BEDMAS, that Exponents Rule, comes into play. I need to do the exponent on this 5 and the exponent on this 12 before I'm allowed to add them together, because exponents comes before addition. So I'm going to do this first. 5 squared. Remember 5 squared means 5 times 5, and that gives me 25. Over here, 12 squared, and remember that means 12 times 12, and that would be 144. So now I have 25 plus 144 is c squared. Well, 25 plus 144 is 169, and that's c squared. Now, I'm almost finished. The problem is I've been given c squared. So if I think about the area of this square, the area of the square is 169 centimeters squared, because I've found the area of A and the area of B, and I get the area of C. But I wasn't asked to find the area. I don't care about c squared. I want what c is by itself. So to get rid of c squared and make it just c, I need to do an opposite operation. The opposite operation of squaring something is to take the square root of that thing. If I take the square root of c squared, it's going to cancel out that exponent of 2. So the square root symbol and the exponent of 2 will cancel each other out, and I'm left with just c. But like when we were solving equations, what I do to one side, I must do to the other. Both sides need to be treated equally. And when I take the square root of 169, I get 13. And so we know now that our missing side length must be 13 meters. Okay? Oh, and earlier I said centimeters squared. That was a mistake. It was meters squared. Good job. Way to pay attention, Mr. T. Okay? So, I wrote my formula. I substituted into my formula the things that I knew. I followed order of operations to deal with my exponents before I did my addition. Once I found my answer equaling c squared, I simply took the square root of both sides to find my final answer for c. Okay, let's do another one. Differently drawn triangle looks a little different. Find the missing side length in the triangle. So again, when I look at this one, the first thing I should notice, I have a 90-degree angle. That's good. And when I look at that 90-degree angle, the side across from it is my hypotenuse. I am missing the length of my hypotenuse. That's the side length that I don't know. Because I have a 90-degree angle in my triangle, I want to start off with a squared plus b squared equals c squared. Okay? Now again, I know the side length I'm missing is my hypotenuse. I know the side length I'm missing is c. I have my two legs of the triangle. I'm going to call my smallest one a. Oops, that was meant to be an equal sign. That didn't work out. A is 9. And I'm going to call 12 b. So now I know that a is 9 centimeters, b is 12 centimeters, and c is some unknown number of centimeters that I don't know yet. Okay, so there's my important information. Now, if you did yours backwards and you called 9 centimeters b and you called the 12 centimeters a, you will still get this question right. You're just going to have a slightly different order than I have. So I'm going to substitute in. Instead of writing a, I fill in that 9, and so a squared becomes 9 squared. Instead of writing b, I fill in that 12, and b becomes 12 squared. And then I still don't have c, so I'm going to leave c squared as it is. Now, I need to evaluate my exponents before I do this addition. Exponents comes before addition when we talk about bed mass. 9 squared means 9 times 9, and that gives me 81. 12 squared means 12 times 12, and that gives me 144. Then I'm going to add the area of those two squares together. 81 plus 144 is 225. So 225 is c squared. But again, I don't want c squared. I didn't want the area of the square off of that side length. I wanted to know what that side length is. If I want to get c instead of c squared, I need to take the square root on both sides. The square root of 225 gives me 15, and the square root of c squared gives me c. And so I know that my side length, that missing side length, must be 15, and I put the units back on it, centimeters. What if in our triangle we already have the biggest side, right? So again, I'm finding the missing length. I notice right away, here's my 90-degree angle. Across from that 90-degree angle is my hypotenuse, and my hypotenuse is 17 millimeters. I already know how big my hypotenuse is. Now I'm missing one of the legs. So I know that C is 17 millimeters. Now, which leg am I missing? Am I missing A or am I missing B? And again, it really doesn't matter. I'm going to call this one B because I think the other one looks smaller. But you know what? It really wouldn't matter if I said B was the one that was missing and I filled in A. Makes no difference at all. So A, in my case, is the one I'm looking for. And I'm going to say that B is 15 millimeters. Now I'm going to start off exactly the same. I've got A squared plus B squared equals C squared. I don't know what A squared is, so it's going to stay as A squared. I do know that B is 15, and so B squared becomes 15 squared. I do know now what C is. C is 17, so C squared becomes 17 squared. Filling in the information, 15 squared would turn into 225. 17 squared would turn into 289. 17 times 17 is 289. I still have this A squared, and now it's A squared plus 225 equals 289. What I need to do here is get A squared all by itself. I need to figure out how big that area of the square off of A is. Now I could probably see and say, well, I've already got 225. How much more do I have to add to it to get it to turn into 289? But again, we also just spent a whole unit solving equations. I can say this is my unknown. This is my variable that I don't know. And 225 is being added to it. Well, the opposite of adding 225 would be subtracting 225 from both sides. This leaves me now with A squared is equal to 289 minus 225 is 64. But I don't want A squared. I want A all by itself. So I need to take the square root of A and the square root of 64. The square root of A squared becomes A. The square root of 64 is 8. And so our missing side length was 8 millimeters. Now what you might see is you might say, well, because I'm looking for A squared, some people what they will do is they will say, take the hypotenuse squared, so the area of the big square, subtract the area of the leg you know, and that will give you A squared. So if you'd like, if you already have the hypotenuse, you could use this as your formula for starting off. Okay, it would still work out just fine. Oops. It would still work out just fine because I'd go 17 squared and that would be 289. And then I would go 15 squared and that would be 225. And 289 minus 225 is equal to 64, and 64 is now A squared, and then when we take the square root, we get 8 is equal to A. We still get the same thing, so if it's easier for you to work with that formula, by all means, feel free to use it. So that's how we use the Pythagorean formula, or the Pythagorean theorem, to find missing side lengths in a triangle.